Hello! In this video, we'll be covering hierarchical clustering, plus advantages and disadvantages. Next, let's look at hierarchical clusters. There are two forms of hierarchical clustering, divisive and agglomerative. Divisive is top-down, so you start with all observations in a large cluster and break it down into smaller pieces. Think about divisive as dividing the cluster. Agglomerative is the opposite of divisive, so it's bottom-up, where each observation starts in its own cluster and pairs of clusters are merged together as they move up the hierarchy. Agglomeration means to amass or collect things, which is exactly what this does with the cluster. A dendrogram shows all of the clusters that have been grouped together. Notice the differences in height. For example, if we're observing this dendrogram with hierarchical agglomerative filtering in mind, then we'll be thinking of grouping clusters rather than splitting. So, let's say two clusters are grouped here, and another two clusters are grouped here. If both of these clusters are grouped together once, how come one is higher than the other? If you look at the y-axis, you can see that it's a measure of distance. Therefore, the higher the point of connection on the dendrogram, the further apart the clusters are from each other. Please note that the same principle of distance measure applies to hierarchical divisive clustering as well. Here's a quick example to reiterate the explanation on the previous slide. Let's assume we have these 5 points. Each of these points are clusters of their own and have not been joined with another cluster yet. Since we're joining the points based on lowest distance, think about the first 2 points that would be joined. Did you say the green and blue points? Well, that would be correct. This join has a small distance, so the height of the dendrogram should also be small. Okay, so what do you think the next join would be? Did you say the red and pink clusters? This distance is larger than the first join we did, so the height should be higher on the dendrogram. So maybe it'll look something like this. Following this logic trail, the next join would be on the 2 clusters we made. The yellow cluster is kind of off on its own. Let's say the distance between these 2 clusters is larger than the distance between the red and purple cluster from the second clustering. This will give us a height that is larger than the second join. Finally, we have 1 clustering left to do, and we need to join those clusters, then draw the final join on the dendrogram. Next, let's review a proximity matrix by using an example. Let's start with 5 different clusters based on different colors: red, green, blue, purple, and yellow, with each color being assigned a letter, A through E. To the right of these clusters, we have the proximity table itself. This table contains the distance measures of all points from each other. So what do you think is the first thing we can label on this table? All proximity tables are centered on a symmetrical diagonal line, and the fields that are being dissected are assigned distances of 0, because the distance from a point to itself is, after all, 0. With that done, let's start filling in this table. Note that the following measurements are not accurate and are just for illustration purposes. Beginning with the red cluster, or A, let's find the measurements of this cluster to each cluster. Let's put these values into the table. Remember that the table is symmetric, so the first column's values are equivalent to the first row's values. Now let's move on from the red cluster since that's completed. Looking at the green cluster, or B, we have the following measurements. Note that we don't need to remeasure to the red cluster because it's been measured once already. Once again, we'll fill in the table with the appropriate values and then remove those distances. By this point, you should have a good idea of how to build this proximity table. So in the interest of saving some time, let's simply fill the rest of the table quickly. And there we go. That is our completed proximity table for this example. There are 3 main advantages to using hierarchical clustering. First, we do not need to specify the number of clusters required for the algorithm. Second, hierarchical clustering is easy to implement. And third, the dendrogram produced is very useful in understanding the data. There are some disadvantages as well. First, the algorithm can never undo any previous steps. So, for example, the algorithm clusters 2 points, and later on we see that the connection was not a good one. The program cannot undo that step. Second, the time complexity for the clustering can result in very long computation times. Finally, if we have a large data set, it can become difficult to determine the correct number of clusters by the dendrogram. Thanks for watching.